All right, guys, I hope you're ready to learn some math today. We are doing something super exciting. We are going to be deriving rules so that we don't have to use limits to do derivatives anymore. Using limits to do derivatives takes a while. It's a little bit clunky. It's a lot of work, and it's important. We want to be able to find the slope of a curved line, but we will be able, at the end of today, to be able to use rules to do things instantly. I don't know if you've looked at your homework yet, but if you were to try to do your homework using the methods we've been using, it would take you like 20 hours to do. And so we're going to spend some work today. It's going to be a bit of a lesson. It's going to be some work. But the work we're going to put in is going to take your homework from taking 20 hours to taking like an hour, right? So it's very much worth it. So we're going to start out by making sure we all are on the same page with some skills. And the first thing we're going to look at is making sure we understand fractional and negative exponents. So I want you to rewrite this as, each one of these is going to be rewritten as x to the a. So you're just rewriting it as x to some power, and you're figuring out what a is. So this is x to what power? And I hope we remember that fraction exponents give us roots. This is x to the 1/2 power. Remember that if there's a fraction power, it's actually a root, and whatever's in the denominator is this part. We don't actually need to write the 2 here because a root with no number automatically means a square. This means a square root. It's the second root. And then this would be x to the 1 power, but we don't actually have to write the 1 because x to the 1 power is 1. So this is what this power means. This is x to the 1/2 power, which is the square root of x. Okay, so hopefully we remember square root powers from before calculus. Let's look at the next one. How do we rewrite this as x to some power? And hopefully we remember that negative exponents tell us to divide. So this is x to the -2 power means 1 over x getting, so the negative means 1 over x squared. And so the power that we needed here was x to the -2 power. Okay, another one to try. What exponent needs to go on x here? So x to what power? We'll make it be the cube root of x squared. And this is, of course, another one of those fraction exponents. The cube root is what goes in the denominator. So that's the denominator because it's a cube root. And it's getting squared, so it's x to the 2/3 power. So remember that whenever we want a fraction power, we know we need it to be this 2/3 power means the denominator is going to be the root, and this is what x is happening. You can also put it as this squared can be here or on the outside. It actually comes out to be the same thing. It's fine. Okay, this next one. How do we rewrite this as x to some power? What power do we need here? And because it's dividing, we should notice that that is negative. It's a negative power, and it's just x to the -1 power because it's 1 over x to the 1 power, and x to the 1 power is x. Okay, last one. How do we rewrite this as x to a power? And we rewrite this as, well, I see it's negative. It's going to be a negative power because it's 1 over. The negative will make it be 1 over. And I see it's going to have a fraction in it because it's a root. There's no number here, so it must be a square root. So that goes in the denominator, and x is not being taken to any power, and so it's to the 1/2 power, x to the -1/2 power. This negative part means it's 1 over, and then x to the 1/2 power means it's a root because it's a fraction, and this is the square root of x to the 1 power, and the square root is just, we just write it like this, and x to the 1 power is just x. So these are the same. Okay. All right, guys, hopefully we feel good about that. We are going to do this because one of the rules we're going to be coming up with today is called the power rule, where if you have x to any power, you will be able to take the derivative of that instantly by the end of today. It's super powerful. But what x to a power means is that, like, because we can do it with x to any power, things that look like this are also just x to any power, in addition to something like this. This is x to a power, but so are all these. And so if you're able to rewrite all the things you're supposed to as x to a power, you'll be able to take the derivative of a lot of things instantly. It's really, really great. Okay. Let's see how we are on our binomial expansions. I don't know if you guys did this last year, but let's see how we do. So what is x plus h to the 0 power? And we should remember that anything to the 0 power is 1. What about x plus h to the 1 power? And we should remember that anything to the 1 power is itself. What about x plus h squared? And we did this in algebra 1, or algebra 2. This is a binomial being squared, and there's a shortcut here. We square the first one, we multiply these two together and double it, and then we square the last one. And there is a shortcut rule for this, but I'm not sure if you know it. But either way, you can still multiply this out. So what is x plus h cubed? This is going to get a little annoying, but multiply it out. And I want to show you one thing that makes this a little bit easier is to recognize that this is x plus h squared times x plus h. And we already did x plus h squared. And so we can take this thing that we already multiplied out, squared, and multiply it by another x plus h. So this will distribute. So we get x cubed plus x squared h. Then this one will distribute, and we get 2xh times x is 2x squared h. 2xh times h is 2xh squared. We need to be a little careful. And lastly, this h squared is going to distribute. And h squared times x, I'm going to put the x first, is xh squared, and h squared times h is h cubed. We need to see, do we have any like terms? And we do. I guess I'll put boxes around these so this doesn't get too confusing. X cubed does not have any like terms. X squared h plus 2x squared h, they're both x squared h's, so this is 3x squared h's. We've got 2xh squared plus 1xh squared, so that's 3xh squareds, and then we've got h cubed by itself. So this is x plus h cubed, kind of annoying. We're going to do x plus h to the 4th. Go ahead and multiply it out. Again, I would suggest using this trick that you can split it up into one we already have multiplied out times another one. So let's see how that goes. So this is, we've already multiplied out. This is x plus h, I'm going to write over here, to the 4th is x plus h times another x plus h cubed. And we've already done x plus h cubed. This is x cubed plus 3x squared h plus 3xh squared plus h cubed. And that is getting multiplied by another x plus h. It doesn't matter what order we multiply them in. Okay, so let's see. X cubed is going to distribute and gets us x to the 4th plus x cubed h. Then 3x squared h is going to distribute. And it's going to get us 3x squared h times x is 3x cubed h. And 3x squared h times h is 3x squared h squared. Now we're going to have 3xh is going to distribute. 3xh squared times x is 3x squared h squared. 3xh squared times h is 3xh cubed. And last, we have the h cubed that's going to need to distribute. Whew, this is getting ugly. I really don't want to do this next one down here. That's x plus h to the 5th. It's getting harder and harder. So this is xh cubed plus h to the 4th. Are there any like terms? X to the 4th, I don't see any other x to the 4ths. I'm going to put that here. X cubed h, here's another x cubed h. We have 1x cubed h plus 3x cubed h, and this is 4x cubed h's. 3x squared h squareds plus 3x squared h squareds is 6x squared h squareds. 3xh cubes plus 1xh cubed is 4xh cubed. And then finally, there is 1h to the 4th. Whew, that was a lot of work. Okay, so in math, a lot of times we want to make sure there isn't as much work. And I hope we notice a few things. We can use math to try to find patterns so that we can do this next to without multiplying it out. Guys, this next one's going to be even worse than this one, and the next one's even worse than that. they get harder and harder to do each time. So let's put in a little work to come up with a pattern. So one thing I notice is that the number of terms, there's one term here, then two terms, then three terms, then four terms, then five terms. And I can probably guess that the number of terms here is going to be how many terms? Well, there's going to be 6 terms because it was 1, then 2, then 3, then 4, then 5. Okay, so that's one pattern. I might also notice that when it was x plus h to the 0, there were no x's. When it was x plus h to the 1, it started with x to the 1, then x squared, then x cubed, then x to the 4th. I can pretty much bet that it's going to start with x to the 5th here because that's the pattern. X to the 0, x to the 1, x squared, x cubed, x to the 4th. I might also notice that it ends with h to the 0, which is 1, then h to the 1, h squared, h to the 3rd, h to the 4th. And so here, what is it probably going to end with? Well, the last term is probably going to be h to the 5th. And I'm going to leave some space here because there's going to be a lot of stuff in between here. Okay, now let's try to think about what's going on in the middle. One thing that I notice is that the terms are decreasing. So let's pick this x to the 4th one. Do you see how it says x to the 4th, then x cubed, then x squared, then x, then no x's? But each time the h's go up. There were no h's, then h squared, then h to the 3rd, then h to the 4th. And if you add the powers, you'll notice they always add up to 4. So it's x to the 3rd, h to the 1. That adds up to 4. X squared, h squared. That adds up to 4. Xh cubed. That adds up to 4. X to the 4th with no h's. H to the 4th with no x's. Same with the third one. The powers always add up to 3. And if there's one that's missing, that's a 1, right? So x to the 1, h squared. And so the powers will always add up to 5 here, okay? The x's go down by 1 each power, and the h's go up by 1 each time. So I can kind of tell what's going to come. This is going to be plus something x to the 4th, h to the 1, because they're still going to add up to 5. And the h's are going up by 1 each time, and the x's are going down. The next one is going to be something x to the what, h to the what. This is going to be x to the 3rd, h squared. Then we're going to get something x to the what, h to the what. Well, the x's are going down, x to the 5th, x to the 4th, x to the 3rd. This is going to be x squared. The h's are going up, h to the 0, h to the 1, h squared, h cubed. And you can kind of double check to make sure it's right because they're adding up to 5. Plus something x h to the 4th, plus last we're going to get h to the 5th. And you'll notice that the x to the n and the h to the n at the end never have a coefficient, but the other ones have these numbers in the middle. And we might notice they're symmetric. So there's like 2 in the middle with 1 and 1 on the side. 1, 3, 3, 1. 1, 4, 6, 4, 1. There's this symmetry where they are symmetric, right? The coefficients are the numbers in front of the variables telling you how many of that term there is. And there's a pattern there as well. And we can see it by making what's called Pascal's triangle. If we take the coefficient here, this was a 1. We're going to put that at the top of Pascal's triangle. The coefficients here were 1 and 1. The coefficients here were 1, 2, and 1. The coefficients here are 1, 3, 3, 1. And the coefficients here are 1, 4, 6, 4, 1. And this is the harder pattern to find, but I put these in this triangle for you. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And now I want you guys to try to fill in. Take a minute, try to figure out the pattern. Some parts of this are easy to find, and there's one part that's a little tricky, but try to fill out what the next row of this pattern would be. And I hope we were able to find that this number will be 1. All of these numbers along the outside are 1. This number will be 1. Maybe we notice that this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But the question is, what are these middle numbers? And maybe you also noticed a way to get this 5 is that it's 1 plus 4, 1 plus 3, 1 plus 2, 2 plus 1. 3 plus 3 is 6. 3 plus 1 is 4. And the way Pascal's triangle works is you can always add the 2 that are right above it to find out what the next number is. So 4 plus 6 is 10. 6 plus 4 is 10. And so this row is going to be 1, 5, 10, 10, 5, 1. And that tells us what the coefficients are for this next row. This was x plus h to the 0. It gives us the coefficients. This is x plus h to the 1. This is x plus h squared. This is x plus h cubed. This is x plus h to the 4th. This one's x plus h to the 5th. And it tells us the coefficients. What about this one? This is x plus h to the 6th. Let's fill this in right here. This was 1x to the 5th plus 5x to the 4th h plus 10 x cubed h squared plus 10 x squared h cubed plus 5 x h to the 4th plus h to the 5th. This next row, fill it out on your own. See what you can do here. Hopefully we got 1, 6, 15, 20, 15, 6, 1, and that's coming because we can add the 2 above it. So 5 plus 10 is 15, 10 plus 10 is 20, 5 plus 10 is 15, and this tells us the coefficients. Putting all of this together, using what the first one should start with, how they add up to the same power each time, the coefficients, and the way it decreases and increases along the way, write out what x plus h to the 6th power will be. You should have gotten that, you know, it's going to be x to the 6th because it always starts with whatever it is to the 6th power. And then I'm going to come back and do the coefficients later. The powers of x go down each time, x to the 5th, and the powers of h go up each time, and they always add up to 6, so 5 plus 1 is 6. Powers of x go down, powers of h go up, always add up to 6. Powers of x go down, powers of h go up. X's keep going down, h's keep going up. 6, 5, 4, 3, 2, 0, 1, 2, 3, 4, and they're always adding up to 6. And I know that the last one always has a coefficient of 1 at the end. And we can use my coefficients here to see what goes here. This is 6, 15, 20, 15, 6, and 1. And so this is x plus h to the 6th power, which would have taken a really long time to multiply out. So that is binomials. This actually comes up not just in what we're doing today, guys, where we're going to use this in just a minute, but it comes up in a lot of areas of math, including statistics, some higher order differential equations. It shows up in a bunch of different places, combinatorics. It shows up in a bunch of places where we want to be able to expand binomials. This is called the binomial theorem. Okay, so let's use our good hard work to calculate these derivatives. We're going to do this on a separate sheet of paper real quick. If f of x equals 1, let's use the limit definition to do this. So we need f of x. So if f of x equals 1, then what is f of x plus h equal to? Well, this means we plug in x plus h in for x, but there's no x's here, so it's also 1. So let's do it. So I'm going to call this g of x. I don't know what I want to call this. I'll call this f of x still. So let's do f prime of x. So if f of x equals 1, f prime of x is the limit as h goes to 0 of f of x plus h, which is 1, minus f of x, which is 1 over h. And we can simplify this. 1 minus 1 is 0, so it's the limit as h goes to 0 of 0 over h. 0 divided by h is 0, so we're not doing the limit yet. Notice if I plug in the limit, I'll get 0 over 0. That's not what I want to do. I want to simplify first. 0 over h is 0, and now I can use direct substitution because there's no h's left. This is 0. So if f of x equals 1, the derivative is 0. And let's take a minute to remember what derivatives are. Remember, derivatives are just the slope. And so what we're saying here is if f of x equals 1, what does f of x equal 1 look like? Well, that's a constant function, where it's the same as saying y equals 1, right? It's a horizontal line where y is 1. And the derivative, f prime of x, means what is the slope at any point? What's the slope of this line at any point? Well, the slope is always 0. So yeah, I sure hope it makes sense that when the function is y equals 1, which looks like this, that the slope is always 0, okay? Let's look at this next one. If f of x equals x, f of x equals x, then we've got f of x plus h would be, we're just plugging in x plus h in for x, so it's x plus h. And so when we do our derivative, the formula for the derivative at any point, that's the h1, it's the limit as h goes to 0 of f of x minus, f of x plus h minus f of x over h. And we should notice that the x's will cancel out. H divided by h is 1. And so this is the limit as h goes to 0 of 1. And again, this is our constant property of limits. As h goes to 0, there are no h's, so the answer is 1. And again, this should make sense. Y equals x is the linear parent function. And so the equation for the slopes is it says that at any point, the slope is 1. Well, yeah, we knew that from Algebra 1, that the slope at any point of this line is 1. In fact, if I had said, guys, f of x equals x, what is f prime of x? You could just think about it and say, well, I know it's asking for the slope, and the slope is 1 everywhere. And so the slope will always be 1 at every point. So this is a formula saying that at every x value, the slope is always 1, which makes sense because it's linear. The slope is always constant. We know that linear functions have a constant slope. That will end here. Now we're getting into like stuff we needed calculus for. So what if f of x is x squared? Okay. Well, f of x plus h, now we get to start using this stuff on our warm-up. F of x plus h means we put in x plus h and do x plus h squared. So what is x plus h squared? Well, we know we can square a binomial by saying it's x squared plus, we multiply these two together and double it, plus h squared. So there's our f of x plus h. And so f prime of x will equal the slope formula at any point for this quadratic. The slope will not be the same at every x now. The slopes are changing different places. Is going to be the limit as h goes to 0 of f of x plus h. F of x plus h is x squared plus 2xh plus h squared minus x squared over h. And I like these parts where they simplify. So all the things that don't have an h always end up canceling out. X squared minus x squared goes away. And what do we do here? What's our technique? Well, we're going to, once you've gotten rid of everything that doesn't have an h, you will always have something that has an h in the top, and so you can factor out the h. So it's h times 2x plus, so h times 2x is 2xh. H times h squared is h over h, and we can cancel out the h's. And so we get the limit as h goes to 0 of 2x plus h. And so h is going to 0, and we get 2x plus 0, which is 2x. And so the derivative is 2x. And notice this isn't a constant. It's saying like, hey, when x is 0, the slope is 0, which makes it a horizontal tangent line. When x is 2, the slope is 4, which makes sense. When x is -1, the slope is -2, which makes sense. The slopes are changing, and this is the formula to find the slopes of this curved line everywhere. Okay, let's do another one. F of x equals x cubed. Let's go back and use our warm-up. And so we already calculated up here. I don't know how to, hold on, I'm gonna do this. This will serve us best. We already did x cubed. And so what is f of x plus h? Well, we talked in our warm-up about how to do x plus h cubed, and x plus h cubed is going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. We're seeing that pattern. The x's are going down, the h's are going up. There's some middle coefficients that we could find from Pascal's triangle. Okay. And so go ahead and do this limit on your own, guys. I feel confident that you can do this, but maybe not. We'll see. So you should have gotten f prime of x equals the limit as h goes to 0 of f of x plus h this is all f of x plus h minus f of x over h. And what's going to cancel? Well, the stuff that doesn't have an h. So x cubed minus x cubed goes away. These all have an h, so we can factor out an h. H times 3x squared. H times 3xh will give me 3xh squared. And h times h squared will give me h to the third, divided by h. And the h's will now cancel out. And now I'm doing the limit as h goes to 0 of 3x squared plus 3xh plus h squared. And all the things with h in it will go to 0. So 3x times 0 is 0, h squared, 0 squared is 0, and so we just get 3x squared. So the derivative is 3x squared. So when we have x cubed, the derivative is 3x squared. Again, it's saying for the cubic parent function, this is a formula that finds us the slope at every x value. When x is 0, the slope is 0 here. When x is 2, the slope is 12. It's super steep. When x is -2, -2 squared is 4. 3 times 4 is 12. The slope is also positive. Notice that the slopes are always positive in the cubic parent function. And they'll always end up positive because x squared is positive. Okay. All right, guys. Instead of continuing on with this, let's try to make use of math and come up with a pattern. We found that when x was 1, f prime of x was 0. When f of x is x, f prime of x is 1. When f of x was x squared, f prime of x was 2x. When f of x is x cubed, f prime of x is 3x squared. I want you to try to use your patterns to try to come up with what you think the next one will be. And I hope you notice that it's going 0, 1, 2, 3. This one will be 4. And I hope you noticed that the x's, there were no x's here, no x's, no x's, x to the 1, x squared, and so I hope you guessed x cubed. Try to continue the pattern. What about x to the 5th? Hopefully you notice it's going 0, 1, 2, 3, 4, 5. The power of x is going up, 0, 0, x to the 1, x squared, x cubed, x to the 4th. Another way to think about it is it's always 1 less than the power. So this is x squared, this is x to the 1. This is x cubed, this is x squared. This is x to the 4th, this is x cubed. This is x to the 5th, this is x to the 4th. So how about these last two? What will the derivative function, what will be the derivative formula be for x to the 6th? Well, it's going to be 6x to the 5th and 7x to the 6th. And let me throw in a little harder one. What about x to the 100th power? Well, it's going to be 100x to the, what power is this going to be? I hope you guys noticed that whatever number this is what we're multiplying by. And then the power is always 1 less than it used to be. So this is 100x to the 99. So whatever the power is, that's what it is. That's what the coefficient becomes. And then the power just goes down by 1. We refer to this as the power rule. If f of x equals x to the n, then the derivative is always going to be you multiply by the power and you lower the power by 1. which we just write as n minus 1. You lower the power by 1. So, x to the 57th, if we want to find what f prime is, what is the formula for this? Well, the derivative would be 57 x to the, we lower the power by 1, 56th. That's it. So, guys, we have a few pages today of things we're going to do. We have, in our notes, we have the power rule, and we're going to come up with this in just a second. I want to actually prove it. We're going to do some high-level stuff. And guys, in just a minute, we're going to prove where these rules come from. This is something that is not tested on the AP exam, but is something that's found in some high-level college stuff. And I know a lot of you are going to be going to UT and Texas A&M and other good schools around the country. And some of you might end up doing some like really high-level math stuff. And so I want to make sure you have seen some of this high-level proofy stuff. This is not tested on the AP exam. And it won't be tested on our test except as a bonus question. We are going to come up with general rules for derivatives. And at the end of the day, we won't have to do any limits. We will use limits to come up with these rules, and then we won't have to use limits anymore. You'll just be able to use these rules. But let's see where they come from. Let's say we have a constant. F of x equals a constant, like f of x equals 5. First of all, let's just do this one graphically. F of x equals 5 looks like this. It's a horizontal line, y equals 5. And so what should the slope formula be? What is the slope going to be at any x? Well, the slope of a horizontal line is 0. This slope is 0. And it doesn't matter whether we're at x equals 6, the slope is 0. If we're at x equals -2, the slope is 0. And so this formula says the slope at any x will always be 0. Now let's actually come up with it. Let's see how we can use limits to come up with this. All through this period, we're going to be using the limit formula where we want to come up with f prime of x equals. So a rule for any x. So which limit definition are we going to be using? We're going to be using the h1, f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. So we do want to know this. This is important to know. And if you haven't memorized it yet, I really strongly, highly recommend making like a flashcard with it. This is the one for the derivative formula, okay? And for this one, if f of x is a constant, then what is f of x plus h? Well, we plug in x plus h in where x is, but there's no x's here. There's only a constant. So there's no x's. So f of x plus h is equal to c also, because there's nothing to plug x plus h into. It's just equal to whatever's there. So let's use this formula. What is, let's write it. It's limit as h goes to 0 of what? Well, f of x plus h is c minus f of x is c over h. And we need to simplify. What can we simplify here? C minus c is 0. And 0 divided by h is 0. And so we're doing the limit as h goes to 0 of 0. And that's just direct substitution. There are no h's. It's the constant properties of limits. And so the derivative is 0. And this tells us that for any function, for any constant function, not just this one, for any constant function, y equals some constant number, like y equals 7, that the derivative will be 0. And of course this should make sense, right? For any constant function, it will be a horizontal line, and the slope for any constant function will always be 0. So whenever you see like y equals 7, or f of x equals 3, or y equals, let me show you a tricky one. Y equals pi. Pi is just a number. It's 3.14. So it's like, oh, here's pi, and y is just going to equal that the whole time. The derivative, the slope at any point is 0. So whenever you have y equals a constant or f of x equals a constant, the slope will be 0. And now let's do the power rule. This is the big thing for the day. F of x equals x to the n. We already said what it was, but let's come up with why it is that way. what is f of x plus h? And here's where we're going to use our work from our warm-up. And in fact, we don't even need to use all the work. We just need to use some of it. We know that it's going to start with, let's go back to, where is our warm-up? Let's go back to the pattern here. We know that x plus h to the n will always start with, this started with x to the 5th. This started with x to the 6th. X plus h to the n is always going to start with x to the n. The next one we know will always have one lower power of x, x to the n minus 1, with an h there. And I'm going to leave the coefficients blank for a second. X to the n minus 2, the powers of n go down by 1 each time, and the powers of h go up by 1 each time. And what about the coefficients? Well, I know the first one always starts with 1, and the second one goes 1, 2, 3, 4, 5, 6. Notice it's always whatever the n is. So the second, oh, you guys couldn't see this. It's so sad. The second, whatever the second term is, so it's these ones are the second term, they follow this easy pattern, 1, 2, 3, 4, 5, 6, where they are whatever power it is. So if it's x to the 5th, the second term is x to the 5th. 5x to the 5th. And so when we have x to the n, so we notice this was 6x to the 5th, 5x to the 4th. This is going to be n x to the n minus 1. And the other coefficients get messy, but it turns out they don't matter. And we'll see why in just a second. I am going to put here that this is x to the n, plus we said this coefficient would be n, x to the n minus 1 times h, plus, I'm going to leave this coefficient blank because I'm going to tell you it doesn't matter, and you'll see why in a second, times x to the n minus 2h squared, plus dot, 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 where the powers of h keep going up and up and up each time. So it's h squared, h cubed. Okay, so let's do our limit. It's the limit is, so f prime of x, you guys can't see that, equals the limit as h goes to 0 of f of x plus h, and so this is x to the n plus n x to the n minus 1 h plus something x to the n minus 2 h squared plus, there's this whole big thing, there's some x's here, there's something, there's x to the something, but h cubed plus something h to the 4th plus dot, dot, dot. We don't even know because we don't know how big n is. But I'm okay with this dot, 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 and you'll see why in a second. Minus, so this is f of x plus h. This is f of x plus h minus f of x, which is x to the n. So this is weird, right? We're coming up with a general rule divided by h. So I'm saying that it doesn't even matter what n is. It'll always follow this pattern, okay? And it doesn't matter what n is. We will always be able to simplify in the exact same way. What can we do here to simplify? Well, the only thing that doesn't have an h are these ones. Everything else has an h. These ones will cancel out. And so what do we do with all of these terms that have h's? We can factor out an h. I'm going to put this down here. This is the limit as h goes to 0 of h times. When we factor out an h, here we'll have n x to the n minus 1 times h will give us n x to the n minus 1h. Plus, I don't even know what this coefficient is, but this is x to the n minus 2, and I factored out an h, so this will now only be h. h times h is h squared. This is going to be something. When I factor out the h, this will be an h squared, and you'll notice that the powers of h will go up something each time, but see that the powers of h are going up by 1 each time. That's the only thing that matters here. Because we're going to simplify. How do we simplify here? Cancel out the h. And now we're going to do the limit as h goes to 0. And you will notice that here there is an h. 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 And the powers of h just keep going up. And as long as there's an h in it, that will go to 0. There was only one of them that when we factored out the h, no longer has an h in it. And so When h goes to 0, all that is left is nx to the n minus 1. And so that is the derivative. The derivative of, if f of x is x to the n, the derivative is n times x to the n minus 1. This is the power rule. So, for example, if f of x is x cubed, the derivative is, we bring the power down, 3 times x squared, and lower the power by 1. Multiply by the power, lower the power by 1. That's the power. What about if f of x equals x to the 15th? What is f prime of x? Go ahead and try to answer that. We multiply by the power, we bring the power down. What about if f of x is x to the 7th? Well, we multiply by the power and lower the power down by 1. That's the power rule. Okay, guys, whew, that was a lot of work, but already we've spent probably like an hour already doing this stuff. You guys have probably spent well over an hour. Maybe our class time is finished. I don't even know. You spent a lot of work on this, but already you have taken problems that would have taken forever, and you've made them so that they will go very quickly. Let's try this here. Guys, try to practice each one of these. If f of x equals x to the 5th, what is the derivative? 5x to the 4th, because we multiply by the power, and we lower the power by 1. X to the 10th, 10x to the 9th. By the way, guys, this would have taken forever. Just this one problem would have taken as much time as we spent this entire, if we had to multiply x plus h out 10 times, that by itself would take probably the entire class period we've had so far. And so the fact that we were able to come up with a rule and do it in seconds is ridiculous. Okay, if f of x equals x squared, the derivative is 2x. We don't put 2x to the 1, x to the 1 is just x. How about f of x equals x? This one's a little bit weird. The derivative, let's think about it like the power rule. What is this power here? This is 1. And so when we multiply by the power, we will get 1 times x to the 0. But x to the 0 is 1. So 1 times 1 is 1. So the derivative, if there's just an x, it'll just be 1. Okay. But it is still the power rule. Let's get to a new one, and we'll do this one together. This may not look like a power rule, but again, this is where your warm-up is coming into play. How do we rewrite this as x to a power? This is x to the 1/2 power. And that's because fraction exponents are roots. Remember, the denominator is what root this is, and this is a square root. And now we can use the power rule. The derivative is going to be, we multiply by the power, 1/2, and we lower the power by 1. So I'm going to do this off to the side here. We have to lower the power by 1. That's the same as subtracting 1. When you're doing this with fractions, you need to have a common denominator. So 1 is 1 over 1. And to make it be a common denominator, we're going to multiply by 2 over 2. So we get 1/2 minus 2 over 2. And now that they have a common denominator, 1 minus 2 is -1 over 2. 1/2 minus 1 is -1/2. When we lower the power by 1, we get the -1/2 power. A shortcut way, since we're going to be doing this a lot real quick, guys, is an easy way to subtract 1 is to just take whatever the denominator is and do the same thing over the same thing. So 2 over 2, because 2 divided by 2 is 1. If it was like 4/3 minus 1, we would do 3 over 3, because 3 over 3 is 1. So whatever the denominator is, you can just put the same number over the same number. Okay, and we never leave fractions or fraction or exponent powers, and so we rewrite this at the end. F prime of x equals, the 1 is in the numerator, 2 is in the denominator, and because of this negative exponent, when there is a negative exponent, that means it will move to the denominator, and x to the -1/2 is the square root of x. So when there are fraction exponents, we need to rewrite them as roots. Negative exponents move to the denominator. Okay, let's see how you guys do on one of these on your own. How do we rewrite this as a power? This is x to the 1/3 power. So when we subtract 1, so when we do this, what is the coefficient going to be? Should be multiplied by the coefficient 1/3 times x to the, what power is it going to be? Well, we have to do 1/3 minus 1. So 1/3 minus, to get the easy way to write 1 is in thirds is 3/3. So 1/3 minus 3/3 is -2/3. Oops, -2/3. And so how do we rewrite that at the end? Well, the 1 is the numerator, the 3 is in the denominator, and because of this negative exponent, this will also be in the denominator. So this is going to be, the denominator is the root. This is the cube root of x squared. So the derivative rule for the cube root of x is 1/3 cube root of x squared. Okay, hopefully we're feeling good about this. How about this one? Why don't you guys try it on your own from start to finish? What is the derivative? And let's see. Hopefully we knew how to change this to a power. This is x to the 2/3 power, because this is a cube root and this is a squared. And so this is x to the 2/3 power. This is the root. This is what x is being taken to. And so the derivative, we need to multiply by the power, so 2/3, and we need to lower the power down by 1. So we're going to put minus 3/3. That's a special way of writing 1. So we're lowering the power down by 1. So it'll be x to the -1/3 power. And we can rewrite this at the end as 2/3. This is x is to the negative power, so it's going to be in the denominator. Cube root of x. We don't need to put x to the 1 here because x to the 1 is just x. So this numerator of 1 doesn't do anything. So there we go, guys. There's one thing that a lot of kids get tripped up on sometimes, and so I want to make sure you have seen an example of this. Let's do, I should have put this in the notes, but f of x equals the square root of x to the 5th. There's something that kids get tripped on. Find what f prime of x is on your own. And hopefully you saw this was x to the 5/2 power because it's a square root. And when we lower the power by 1, we're going to do minus 2/2. And this is, so f prime of x, the power is 5/2, so it's going to be 5/2 x to the 3/2 power. And then the thing that throws people off sometimes is this does not go to the denominator. A lot of kids get used to like writing things in the denominator, but this is not a negative exponent. So we write 5/2, and then right next to it, we would write the square root of x cubed. Notice it is not in the denominator. It's also fine to put it in the, you could put it in the numerator like this. This is okay, but usually we think of 5/2 as the coefficient and it multiplying by x to the 3/2 power here. Okay, so don't automatically put things in the denominator. You only do that if this had been a negative exponent, then it would go in the denominator. But if it's not, it doesn't. Okay. All right, how about this next one? What power of x is this? This is x to the -1 power. And so the derivative, the power rule says we will multiply by -1. We don't have to put the 1 here. We'll just put negative, because multiplying by -1 is just making a thing negative. X to the, now we have to lower the power by 1. -1 minus 1, if you're down at -1, and you go down even further, you're now at -2. So some kids have some trouble with negative numbers still. If you're at a negative and you go down by 1, you're even more negative now. And so we always rewrite at the end. We never leave negative exponents in our answer. A negative exponent means you're dividing. So this is negative. We do need something in the numerator, so we're going to put a 1 over x squared. The negative exponent means we are dividing by x squared. And since there was nothing left in the numerator, we put a 1 there. If this had been like -5x to the -2, we would just put -5 over x squared, and we wouldn't need a 1 on top. But because there was nothing left in the numerator, we had to put a 1. All right, guys, here's some to try on your own. What is f prime of x? And hopefully we know that to get this as a power rule, we need to rewrite it as x to the negative 2 power. And then we're going to put f prime of x will be negative 2 x to the, we need to lower the power by 1, negative 3. Okay, we rewrite negative exponents as negative 2 over x cubed. Okay, guys, one thing I want to point out is that with limit rules, you were able to just do whatever you wanted and things came out right. And that is not true at all with derivative rules. For instance, sometimes kids will be like, okay, I see that this is, so f of x, let's take this example with 1 over x squared. I see x squared, I'm going to lower this power by 1 and multiply by the power, and so the derivative is 1 over 2x. And this is absolutely wrong. Is that what the derivative came out to be? No, it's negative 2 over x cubed. You can't just take parts of things and start doing them like we could with limits. You need to follow the rule. If you have a fraction, you cannot do the derivative unless you can rewrite it so that there's no fraction. So a fraction, you don't know how to do the derivative yet. There is a way to do it, but instead we need to be able to rewrite it as just x to some power because we know the rule for x to some power. You cannot be like, oh, I'm going to be like, oh, 1 over 4. You can't take this one and be like, it's going to be 4x cubed because I multiplied by the 4 and lowered the power by 1. This is going to be dead wrong, and you'll see that in just a second. Go ahead and do this derivative the right way by rewriting it as a power. I just want to point out, you don't get to make up your own rules anymore. You actually have to follow the procedure pretty well. Okay, hopefully we found f prime of x here, and this is x to the negative 4th power. And so when we do the derivative, we will multiply by the power and lower the power by 1. So negative 4 minus 1 is negative 5. And we always rewrite at the end, this is negative 4 over x to the 5th power because it was a negative exponent. Okay, guys, really quickly, one other thing I want to point out is that labeling is incredibly important here. And I feel like, not having been in class, we haven't gotten this as strongly as I would like, because this is where like me going around looking at the stuff and being like, oh, you didn't label this right. I could tell you that stuff all the time and you would have it by now. But you'll notice that I'm always very careful to label things correctly here. This one is f of x, and I put equals x to the 1/2. This isn't f prime yet. This is not a formula for the slopes. This is still the original function written in a different way. As soon as I do the power rule and multiply and lower the exponent, now it's the derivative, and I've put the derivative equals this. And then I'm rewriting it still the slope formula. So these are slopes, and this is the original function, okay? This is about y values, and these are about slopes. I sometimes see kids like kind of mix and match where they're like, so f of x equals x, 1 over x to the 5th, and they'll be like, f of x equals x to the negative 5th, which is great so far, and then they'll put f of x equals negative 5 x to the negative 6, f prime of x equals negative 5 over x to the 6th. And this has a very serious error in it. Which one of these steps? Is it 1, 2, 3, or 4 that is wrong? 3 of these are correct statements, but one of these is wrong. Which one? The wrong statement is number 3. And the reason the wrong statement is number 3 is because this is not f of x anymore. We have lowered the power. We have multiplied by the power. We did the power rule. This is now the derivative. This is not a formula for the y values anymore. This is a formula for the slopes. These two are the same, and they are both the slope formula. These two are the same. They are both the function values. These are y values. These are slopes. These are y values, and they are not the same. And so we need to be careful about our labeling, okay? This will come up even more when we start mixing and matching rules soon. Okay, guys, rewrite this. What is this rewritten as a power? Go ahead and just find the derivative, see if you can do it. And if not, I'll go through it with you. This is x to the negative power because it's 1 over. and it's a root, so it's going to be a fraction. It's the square root, so the 2 is in the denominator, and it's not x to anything, so it's x to the negative 1/2 power. So the derivative, so this is still a slope. This is still a y value, not a slope yet. And now the slope is when I multiply, it's going to be negative 1/2 times x to the, we need to lower the power by 1, so negative 1/2 minus, the denominator's 2, so I'm going to put 2 over 2 here. And they both have halves now. Negative 1 minus 2 is negative 3. If I'm at negative 1 and I go down by 2, I'm at negative 3. So negative 3 halves. And so rewriting this at the end, this is negative 1 over 2. This one has a negative in it, so it's going to go to the denominator. It's a square root, because that's in the denominator, of x cubed. And this cube could go inside or outside. It doesn't really matter. Lastly, f of x equals 8. And hopefully we remember that f prime of x equals 0 for any constant function. Remember, this is just y equals 8. The slope is always 0. If you wanted to do the power rule, you would need to think of this as x to the 0 power. And so x is getting multiplied, 8 is getting multiplied by 0, and 0 times anything is 0, which is where it comes from. Okay. A new rule, guys. We are going to derive this. This is going to be, we're going to derive 2 new rules. My goodness, this lesson is getting long. I really hope you've gotten a bunch right, because if you've gotten a bunch right, it skipped you over probably like 15, 20 minutes by now. If you have not gotten a bunch right, this is a very long lesson. Okay. What if we have g of x equals c times some function we already know? So c is some constant. So maybe it's like 7 times sine of x. Do you guys remember the derivative of sine of x? We came up with it the other day. So if f of x equals sine of x, what was f prime of x? Hopefully you remember and memorize this. It's cosine of x. We came up with that at the end of last class using limit properties. Okay, so if g of x equals 7 times sine of x, how do we deal with the 7? We know that cosine of x is the derivative of sine of x, but what about this constant multiplier? What does it do? Well, let's use our limit rules to try to come up with how this works. So the general formula for g prime of x is, the general formula one is the h1. It's the limit as h goes to 0 of, we need g of x plus h. So g of x plus h means we just put in x plus h here. And when we plug in x plus h, we get c times f of x plus h. So that's what g of x plus h is. So c times f of x plus h minus g of x. G of x is c f of x over h. Now, you cannot like cancel out these x's or something. This is inside of a function, and you're not allowed to mess around with what's inside of a function. So take a minute here and see if you can see what is a legal move we can do. What is something we're allowed to do here? And I hope you noticed that they have a common factor of c. And when we have a common factor of c, we can factor it out. And remember, limit property said if you had a constant multiple, you could pull it outside of the limit. So our limit property says we can pull that c outside of the limit. So c times, the limit as h goes to 0, of f of x plus h minus f of x over h. And hopefully you recognize something here. I'll give you a chance to recognize something here. What is this that we see here? This is the limit definition of the derivative of f of x. This is f prime of x. It's literally the definition of the derivative. And so this is c times f prime of x. There's no algebra you can do to combine things here. This is just the definition of the derivative we've been using for a while. Literally like what we have written up at the top of our page here. F prime of x equals this. Well, so if we see this, this is f prime of x. So be on the lookout for this. So this says that if g of x is a constant times a function we know, then the derivative is you just leave the constant alone and do the derivative of the function you know like normal. Let's look at an example. If you have 2x squared, well, this is 2 times a function, a power rule 1. the derivative rule now says that if we have a constant multiplying times a function we know how to do the derivative of, we just leave the constant alone and multiply times the derivative of x squared. The derivative of x squared is 2 times, so we multiply by the power, and we lower the power by 1. And x to the 1 is just x. So we can multiply 2 times 2 together and get 4x. So the derivative of 2x squared is 4x. What about the derivative of, what about if f of x equals 7x to the 4th? Go ahead and find the derivative there. Well, the derivative will be, we're going to leave the 7 alone and do the derivative of this guy. This is going to be 4 times x, we lower the power by 1, cubed. 7 times 4 is 28x cubed. That's the derivative. A trick you might notice with power rule ones is you can just multiply 4 times 7 directly. So 4 times 7 is 28 and lower the power by 1. And that's really useful when you have like y equals 100, x to the 3rd. The derivative, we're going to leave the constant alone and do the derivative of this one. But when we do the derivative of this, it will multiply by 3. So 300, lower the power by 1, x squared. And it gets pretty quick. One more, let's do that one we had up there. If y equals 7 sine of x, then what is the derivative? Y prime is, we leave the derivative alone, the constant alone, and we multiply by the derivative of sine of x, which was cosine of x. That's it. Okay, one more. This is our last thing we're going to come up with today. Thank God, these lessons have been going a little bit long. I'll try to make the next one shorter. What if we have adding or subtracting two functions we know the derivative of? So for instance, we've got like, so like we have, this is a power rule one, this is a power rule one, they're adding together. What do we do with them? Well, let's do our general formula. The formula for the derivative of h of x is, it's going to be the limit. I shouldn't have used h here. Can I call this m? I'm going to call this m of x, guys. And so we're going to do m prime of x equals the limit as, because there's always this limit as h goes to 0, and I think it would get confusing with two h's in there. And why is this so blurry? Okay, maybe it's like focusing on my fingers or something. The limit is h goes to 0 of, it's going to be m of x plus h minus m of x over h. And so what is m of x plus h? M of x plus h means we plug in x plus h for all the x's. And so that's equal to f of x plus h plus or minus, I'm just going to use plus here for now, it comes out the same with minus, plus g of x plus h. So if I put in x plus h in for x, I get f of x plus h plus g of x plus h. So here is f of x plus h minus, we need to remember to put this in parentheses, f of x, m of x is f of x plus g of x. So this is m of x plus h, this is m of x, all over h. And so this is the limit as h goes to 0 of f of x plus h plus g of x plus h minus f of x minus g of x. And I want you to just spend a few minutes looking at this and seeing, do you have any ideas on what we might do? And the answer might be no, and that's okay. Okay, now that you've had a chance to look at it for a minute, I'm going to give you a hint. We are going to split this up using limit properties into two separate limits. They're going to both be over h because we need a common denominator so that when we actually add them up, they give us these two things. So I want you to guess how we should split these up. So look for a second, think how we should split these up. And hopefully you notice that it's probably a good idea to group the f's together and the g's together. So this is f of x plus h minus f of x, g of x plus h minus g of x. And a lot of times in math, we're just like looking for things we could maybe do. And this was something we maybe could do is to regroup them. Regrouping is a strategy that helps sometimes. And now you should notice something. What is this? And I hope we notice that this is the limit definition of the derivative. This is f prime of x. This is the derivative of f of x. And what is this one? Hopefully we notice that this is the derivative of g of x. It's the definition of the derivative for g of x. And so this is the overall formula for the derivative of m of x. If you have a function that's two functions adding or subtracting together, then the derivative will be the derivative of them individually. And this is actually a kind of rule you would expect to be true. If you have two functions adding together, you just like do the derivative of them separately. It's a really nice rule, and it's the same as if they're subtracting. So if they're adding or subtracting, you just leave them adding or subtracting. So let's look at how that looks. If we have these two things subtracting, adding or subtracting, we can just do the derivative of each of these. Now, this one needs to be rewritten because it's not a power rule right now. What I do not want to see, this is very, very bad, and I see kids do it sometimes. Do not be this person. Is they'll be like f prime of x equals 300x to the 99th power plus x to the negative 5th, and then they'll try to do this. What is bad about this right now? Well, the problem is I have done the derivative of this one, but this is not the derivative of this. This is actually still the exact same y value. I haven't done any derivative rules. I've just rewritten it. And so if you have more than one rule, you want to start by rewriting all the things you need to rewrite before you start doing any derivatives, and keep it labeled as f of x. We aren't doing derivatives rules yet. We're just rewriting it in a way that we can do the derivative of everything. So I didn't do anything with this one, but I needed to rewrite it. I needed to rewrite this one. This is x to the negative 5th. And so instead of like starting to do derivative rules, this is like oh, you have a mastery quiz on this stuff coming up, by the way. Instead of starting to do derivatives on like one part and not the other part, we do the derivative on the whole thing at once. And so we need to rewrite everything first, and make sure your labeling is good here. This is f of x still. And now we will do the derivative, and we will multiply by the power and lower the power by 1. And we will multiply by the power here. We don't put plus negative 5. Adding a negative is the same as subtracting. So minus 5. X to the, we need to lower this power by 1. Negative 5 minus 1 is negative 6. And then at the end, we can rewrite any things we need to. This doesn't need to be rewritten, but this one has a negative exponent. And so we will rewrite it negative 5 over x to the 6th. Okay, guys, so let's try this out. We will use these two rules. So here are in our notes, the constant multiplier rule. And again, guys, real quick, this is called derivations, where you find where the rules come from the definitions. I don't expect you to be able to do these by yourself, except as a bonus problem. So like, this won't be on the AP exam coming up with them. What is on the AP exam is being able to use these rules. But it's important in math, in my mind, especially at high level math, to see where things come from. So we spent a little bit of extra time on that. Okay. Let's use this. Let's see how we do. F prime of x equals, the constant multiplier rule says that we can just leave this alone, this constant multiplier here, times the derivative of x squared, which is 2x. We multiply by the power and lower the power by 1, and x to the 1 is just x. 3 times 2 is 6, x. The shorter way to do it is just 2 times 3 is 6, and lower the power by 1, x. Okay. Here, find f prime of x. Hopefully we realize that this is not a power rule right now. We need to rewrite it. To rewrite this, this is 2 times x to the negative 4th. Notice that the 2 doesn't have a negative on it or anything. The 2 is just in the numerator. So 2 times x to the negative 4th. So the derivative is going to be multiply. 2 times negative 4 is negative 8. X to the, we need to lower the power by 1, negative 5. The negative 8 will stay on top over x to the 5th. Okay. This next one, what is the derivative? Well, we know that this can be rewritten as 2 times x to what power? Well, it's a negative power because it was in the denominator, and it's a fraction because it's a root. So 2 times x to the negative 1/2 power is what this one was equal to. It's a negative power because we're dividing, and it's a fraction power because it's a root. Now we can do the derivative because it's a power rule. Negative 1/2 multiplies times 2 to give me negative 1. I'm not going to write the 1 because 1 times anything is itself. And we need to lower the power by 1. So negative 1/2 minus 2/2 is negative 3/2. And last, I need to rewrite this. This is negative 1 over, it's over because it's a negative power, over, over the square root of x cubed. So over the square root of x cubed. Okay. This next one, we need to rewrite. Guys, when we rewrite this, this is 6/4 x to the negative 2. And you can simplify this if you want. This can be simplified. It might make it a little easier, or we can simplify it at the end. I'm going to go ahead and simplify it right now. This is 3/2 x to the negative 2. And so when we multiply 3/2 times negative 2, multiplying and dividing by the same thing cancels out. It's a nice trick. It's 3 times negative 1 is negative 3. The power goes down by 1, x to the negative 3. And so now we can rewrite it as negative 3 over x cubed. Okay. All right, these are actually a little bit easier. These are sums and differences. This happens all the time. Let's do one together real quick. No, you guys can do it. You guys can do it. But let's see how you did. So we multiply by these are sums and differences, so we can just do each one separately. That was our sum and difference rule. It says we can do them separately. The derivative of x cubed is 3x squared, and we can just do separately. What is the derivative of 4x? Remember that the derivative of just an x is 1. The derivative of x is 1, and so 4 times 1 is just 4. And the derivative of 5, remember that the derivative of a constant is 0. And so the derivative is 3x squared minus 4. So these become really easy after a little while, but they are slightly different for some kids. Remember that x to the 1 power, when you multiply it, becomes 1x to the 0 power, which is 1. And so it's important to remember that if there's just an x, it becomes 1. And if there's a constant, it becomes 0. That's our constant rule. Okay, let's see how well you remember these ones from the other day. These need to be memorized. You don't want to have to do a limit definition every time. So f prime of x equals, let's see how you guys did, negative 6x squared plus 18x. The derivative of cosine is negative sine of x. And the derivative of sine of x is cosine of x. So we leave the constant multiplier alone, and we bring it down. Notice that when there is adding a constant, that goes to 0. But if the constant is multiplying, we need to multiply by that constant. Okay, last one, and I think this one should go pretty well for you. You should be starting to get the hang of it. We multiply, 4 times 3 is 12, lower the power by 1. We multiply, 3 times negative 2 is negative 6, lower the power by 1. We multiply, 2 times 5 is 10, lower the power by 1. Now it's x to the 1 power, which is just x, and the derivative of a constant is 0, and so that's not going to be there. Woo! Guys, this is our longest lesson of the year so far. It's also super important. So, like I said, you cannot make up your own rules. You do not get to make up your own rules and be like, I'm going to do the derivatives of parts of these and then multiply them at the end. That's not a thing. It will come out wrong. These are two things that are multiplying. We have not learned a rule for what happens if there are two functions that are multiplying, unless one of them is a constant. If one of them is a constant, you leave the constant alone and do the derivative of the other one. But that does not work for multiplying. There are completely different rules for multiplying and dividing things. And so that's what's up here, guys. I think I'm going to split this into two. Okay. So what we need to do is we need to be able to rewrite it as something we can do. So when you see two functions multiplying, well, you know how to multiply it out. We can just distribute. That's how we can multiply. We can rewrite it. Notice I'm not putting y prime yet. This is not the derivative. I'm just rewriting this in a different way. 2x squared times 3x cubed is 6x to the 5th. 2x squared times negative 2x is negative 4x cubed. Now I'm going to distribute this one. 3x times this is 9x to the 4th. 3x times negative 2x is negative 6x squared. And now I can do the derivative because it's just the sum and difference rule. The sum and difference rule says we can just do them each separately. So we can't do them separately when they're multiplying. You couldn't be like, oh, this is going to be 4x plus 3 times 9x squared minus 2. This is so bad. Don't ever do this. If there are two things multiplying, you can't just do them separately. Only when they're adding and subtracting can you do them separately. But now we can. The derivative, y prime, notice I've switched over from y to y prime now because I'm about to do the power rule, is I multiply 30x to the 4th minus 12x squared, multiply and lower the power, multiply and lower the power, and I'm going to multiply and lower the power. Now there's just an x there. X to the 1 is x. Same idea here. This cannot be done. You can't just like do the derivative of the top divided by the derivative of the bottom. That is not how derivatives work. It would be wrong. We don't have a rule for if there's like g of x over h of x. You cannot do just take the derivative of the top divided by the derivative of the bottom. Don't ever do stuff like that. You don't get to make up your own rules here. The derivative rules get real weird. So you can only stick to the rules you've learned. This is not just a sum and difference. There's this dividing part that's messing it up. But what are we allowed to do? Well, we can just, it's dividing by a monomial, and dividing distributes. You guys know from Algebra 1 that if you have like 3x plus 6 divided by 3, you just divide 3x by 3, and you divide 6 by 3. It's the same thing with variables. Hopefully you feel good about this from pre-calculus. 3x cubed divided by x squared, we can rewrite as, so x cubed divided by x squared, the x's cancel out, and we end up getting only 1x left over. Here, x squared divided by x squared is just 1, so there aren't any x's left over. And 5 divided by x squared, nothing cancels out. The 5 is still on top, and the x squared is still on the bottom. Here, there were more x's on the top than the bottom, and so we weren't dividing anymore. But here, there were more x's on the bottom, and so we need to be a little careful there. And now this is something we can do because this one can be rewritten as a power rule. We couldn't do a dividing rule on this. We don't know any dividing rules, but we can rewrite this as 5x to the negative 2 power. So I'm just going to rewrite it just like right there so I don't have to rewrite everything. So this is the derivative of x is just 1. The derivative of 2 is 0. And the derivative of 5x to the negative 2, we multiply by the negative 2. So negative 10 x to the, we need to lower the power by 1, negative 3. And I need to rewrite at the end. This is 3 minus 10 divided by x cubed. Okay. Let's do some applications. What are some of the ways derivative questions could come up? Find the slope of the line tangent to 3x squared at x equals 4. Well, the slope of the tangent line should set off alarm bells in your head. The slope of the tangent line is the derivative at whatever point we're looking at. So the slope of remember, the slope of the tangent line is a way of asking for the derivative. What is the slope of the function? That's what the derivative tells us. So this is asking us to find the derivative at x equals 4. The way we find the derivative at x equals 4 is we first find a formula for the derivative at any point. So we find the derivative formula, which is easy. And then we want the derivative at x equals 4. You will notice that instead of putting f prime of 4, I'm now putting f prime of x, I'm putting f prime of 4. This one says this is a formula to find the slope at any x. It'll be 6 times x. This says this is the slope at 4, which is what it was actually asking for. And that is 6 times 4, which is 24. And that is the answer. The slope of the tangent line for 3x squared is 24. It's like super steep by the time you get to x equals 4. The slope is 24. And notice, we could have done this by putting in, you know, like, let's think about how we did this on the first, I believe you actually had No, you didn't. It was a function very much like this. You could put in 4 and f of 4, which is 48. You could put in 4.001 and use a calculator to find out this will be like 48 point, it'll be like 48 point, like 48.024, I don't know, something like that. It comes out to something like that. I'm not doing this as a calculator. I might be wrong, guys. Don't hold me to this, but I bet it comes out to be that. And then you'll do like y2 minus y1, 48.024 minus, oh, this was wrong. It was 02. Why was this? Why did I get, what is this? Oh, this should just be, yeah, that's right. So 48.024 minus 48 over x2 minus x1, and, it'll come out to be 0.024 over 0.001, which is 24, And this is so much more work than just looking at it and being like, oh, the derivative formula is 6x, and you plug in 4, and you get 24. Like, this takes so long, and this is so fast. I hope you're really enjoying these new skills we have. Find the equation of the tangent line. So, always think to yourself, what is the question asking? The equation of the tangent line is asking you to find what equation the tangent line has, and we need the slope and a point at x equals 1. So they've given us the x equals 1. So we've got the 1. We can plug it in to get y1. So that's our point. So 1 comma, when x is 1, 1 squared is 1, 3 divided by 1 is 3. So we've got our point. And now we need the slope. And we'll use our derivative formula. How do we do the derivative of this? Well, this needs to be rewritten as a power rule, 3x to the negative 2. And so y prime will be negative 6x to the negative 3 power. We need to lower the power down by 1. So we multiply and lower the power down by 1. And we rewrite this as negative 6 over x cubed. A negative power means dividing. And now we can just plug in 1. So y prime at 1. So this is a formula for the slopes. This is now the slope at a single point. Y prime of 1 is negative 6 over 1 cubed. 1 times 1 times 1 is 1. And negative 6 over 1 is negative 6. So we're writing the equation of the tangent line. Y equals negative 6 times x minus 1 plus 3. The slope times x minus x1 plus y1. Okay, try this one on your own from start to finish. And hopefully you realize that it's asking you to find the equation of the tangent line. That's y equals the slope times x minus x1 plus y1. What are the things you need to find the equation of the tangent line? Well, you need the derivative will tell you the slopes. That's how we find the slopes. And we need a point. It gave us the x value of the point, and we need to plug it in to find the y value. So 4 cubed, 4 times 4 times 4 is 64. And the square root of 64 is 8. I will tell you, I actually think it's easier to rewrite it as square root of x cubed like this, where you do the square root first and then cube it. The square root of 4 is 2. 2 times 2 times 2 is 8. It's smaller numbers, and these are the same. The 3 can be on the inside or the outside. So I've got my point. Now I need to find my slope. Here I need y prime. And before, I'm going to make a mistake here. You tell me what's wrong here. Y prime equals x to the 3/2 power. What was my mistake? Well, this isn't y prime. This is still just y. I was just rewriting it. I have not used the power rule. I've not lowered the power by 1. I've not multiplied by the power. And so this is just another way of writing the y values. Don't put y prime there. And now when we do the power rule, I'll multiply by 3/2. I need to lower the power by 1. 3/2 minus 2/2 is 1/2, and this is the derivative. Y prime equals, I'm going to make a mistake here, and you tell me what it is. Oh, man, you guys couldn't see this. The mistake here, I hope we saw, is that this should not be in the denominator. It is not a negative exponent. This should be 3/2 times the square root of x. Okay, so 3/2 times the square root of x. And so y prime at x equals 4 is 3/2 times the square root of 4. Square root of 4 is 2. and 3/2 times 2 will just be 3. Multiplying and dividing by 2 cancel out. And so the slope is 3. So the equation of the tangent line then is y equals 3 times x minus 4 plus 8. Whoo! Okay. Guys, what is something you cannot do here? What are you not allowed to do? You cannot just do the derivative of this times the derivative of this. That is not a thing. There is no rule that says you can do the derivative of two things multiplying. In fact, you don't know a rule for this yet at all. And so since you don't know a rule for two things multiplying, you need to simplify it to a way that you can do it. So this is not f prime of x. I'm just rewriting it. Simplify this, and you should have gotten x cubed plus 4x squared minus x squared minus 4x. And then f prime of, oh, can I combine like terms? Okay, so this is not f prime of x yet, because I'm just going to combine like terms. I'm not doing any derivatives. Plus 3x squared minus 4x. Notice I could have taken the derivative of this one already as I combine these two, but I'm going to do the derivative of all of it at once. And so I want to make sure it's all written in a way I can take the derivative of. So f prime of x equals 3x squared plus 6x minus 4. We multiply by the power, lower the power by 1. Multiply by the power, lower the power by 1. Remember that the derivative of x is just 1. Okay. Ooh, this is a harder question. Find the points, if any, at which the function y equals x cubed plus x has a horizontal tangent line. So there's some function, and they want to know where it has a horizontal tangent line. This comes up on the AP exam fairly often. What does it mean for a function to have a horizontal tangent line? Well, what we know about horizontal tangent lines is that the slope is 0. And the slope we find by finding f prime of x. And so it's saying that the f prime of x needs to equal 0. That's not x equals 0 that we plug into f prime of x. It's saying we take the derivative and find where it's equal to 0. So this is the equation for some cubic, and we want to find where its slope is 0, where it will have a horizontal tangent line. So we're going to find the slope. What is the derivative? Well, y prime equals 3x squared plus 1. The derivative of x is 1. And this slope needs to be 0. This is setting up an equation to solve. Where is the slope going to be equal to 0? Where will the slope be horizontal? And we can solve this from algebra 1 or algebra 2. We get x by itself. So we're going to say subtract 1, divide by 3, x squared equals negative 1/3. We take the square root. And we should notice something here. We are doing the square root of a negative. This is imaginary. And so let's answer the question. Find the points where x cubed plus x has a horizontal tangent line. And the answer is there are none. There are no real x values that have a horizontal tangent line for this function, because when we did the slope formula, the slope is never equal to 0. So tricky. All right, here is a new skill. Look at this closely. What's different about this? You may notice it has f prime prime of x. This is the second derivative. We'll talk more about what the second derivative means later, but it just means you do the derivative twice. It's the derivative of the derivative. You just do the derivative twice. It's the slope of the slopes, which is weird. So the way we do it is we just find the derivative first, just like normal. So what is the derivative of this? 12x cubed. We multiply and lower the power. We multiply and lower the power. This is 0. And we do the derivative of sine of x. The derivative of sine of x is cosine of x. And then, that's the first derivative. We find the slope of the slope. We find the slope of this function. And that's the derivative again. So multiply by the power, lower the power by 1. Multiply by the power, lower by the power by 1. Remember, the derivative of x is just 1. And the derivative of cosine of x you need to have memorized. The derivative of cosine is negative sine of x. And that is it here, guys. Those are a bunch of things we've learned. I hope you have a good time practicing on your homework, and have a good rest of your day.